Good morning. I hope you had a good restful break. And we're going to start off with translations. When you translate something, a point, a shape, you're moving it left and right or up and down. And to translate, it does not change shape. Like it doesn't get smaller, it doesn't get bigger, it doesn't stretch in any way, and it doesn't flip. It doesn't rotate and tilt. It stays in the exact same orientation. It just relocates. So for example, we're going to start with this dot right here. We're going to put a point on the spot, let's say 2, 3. And there it is. And we're going to now translate that point to the right 4. And so when you're moving something right or left, you're affecting the x value. So if he is at 2, 3, and we're going to move him to the right 4, he's going to end up where? He's going to end up 2 plus 4, which is 6. So his new location is going to be 6, 3. And that is with a translation to the right 4 units. So here we see our original point, 2, 3, and we have translated that point to the right 4 units. And the way that looks is if you look at the algebraic notation underneath 6, 3, it says x plus 4, y. Because remember, just like with the reflection, you had a pre-image and then you had the reflected image. Here you have the original point. We don't call it the pre-point or the pre-image, but this 2, 3 was the original point, and 6, 3 is the translated point. And that translated point is the old point plus 4 more units to the right of the x value. Notice the y stays the same, 3, 3. But the x value shifted to the right 4 units. This probably sounds more complicated than it needs to be. It's actually a pretty simple, easy concept, but it's new, and so it's going to take a few times to just really digest. So let's take a look at another point. Here we have the point 5, 2. And I want to translate this point to the left 3 places. So where would the location of that new point be? See, we went to the left, so therefore our new location is 2, 2. That's a translation to the left 3 places. So what does that look like algebraically? Again, the y value doesn't change. It's still 2 up from the x-axis. However, the x value changed. It reduced the original value of x by 3 units. Therefore, the algebraic notation of the new point is x minus 3, y. So now let me give you one. It's going to be a right or a left, and you practice. The blue point is our original point. The red point is our translated point, our new location. What would the algebraic expression be for the new point using x and y's? If you said x plus 5, y, you'd be correct, because all we did was move to the right 5 units, and when you shift to the right, you add 5 to the x value. Let's try one more. Here we have the blue point as our first point and the red point as our translated point. What is the algebraic expression of this translation? If you said x plus 4, y, you'd be correct. Again, the original point was the blue point. We translated to the right 4 units to get to the new point. Even though we crossed the y-axis, that has no bearing on the algebraic notation and the amount of units we had to move to the right. So it would still be x plus 4, y. Again, there's been no change to the y yet, but let's explore that. What happens if we translate down as opposed to translating to the right or left? What does that look like? Well, we translated down 2 units. So let's see, can you predict what the algebraic expression will look like? If you said x comma y minus 2, you'd be correct. Because again, the blue point is our original point. The red point is our new location. And how do I get from the old point to the new point? I have to go down 2 units. When you translate down, it's negative. When you translate up, it's positive. And this changes the y value, not the x value. Therefore, this was a translation down 2 units. What about a translation down and a translation to the right? Stop and think, what would that notation look like? If you said x plus 1, y minus 2, you'd be correct. We had to go to the right 1 unit, which changes the x value, and down 2 units, which changes the y value. Think about the coordinate plane. When we go to the right, it's positive. When we go up, the y values are positive. When we go down, the y values are negative. And when we go to the left, the x values are negative. So even though both of these locations are still in the x negative quadrant, we had to go 1 unit to the right. Therefore, we had to add 1 to the x value. We had to go down 2 units, so we had to take away 2 units from the y value. Okay, let's try this one. What would the algebraic notation look like in this transformation? If you observed that the new point is a translation up 1 and to the left 3, you'd be correct. But don't forget, up 1 affects the y value. Left 3 affects the x value. So I want you to pay close attention to the values that you're going to be changing. Here we want to always address the x value first, for no other reason, just for simple organization. The old point was in blue, the new location is in red. So we see that the new location is 3 units to the left. And whenever we translate to the left, we're going to go minus 3. This way would be plus 3, but we didn't go to the right. To the left is minus 3. So our first point is x minus 3. So what happened to the y value? Well, the y value went up 1. So y plus 1. So the algebraic notation from the blue point to the red point is x minus 3, y plus 1. I hope that's enough information to get you going on today's activity. It's a Desmos activity. You guys did one of these a couple weeks ago. There's going to be 4 cards with points on them. You need to move them with the algebraic notation and the verbal description and use them like magnets. They will stick together. So at some point, you will have a card of points, a card of verbal description, and a card with the algebraic notation, and they should all get stuck together as one group. You'll have 4 total groups when you're finished. Good luck.